Welcome back everyone, and for today's video we're going to be looking at LeetCode problem number 200, number of islands. So let's go ahead and jump right into it. So we're given a 2D array and it has m number of rows and n number of columns, and the name of the 2D array is called grid. And on each cell of our grid we are going to have either a 1 character or a 0 character. And important to note is that these are not integers, and that can really screw you up when you're writing your code, so be sure to take note of that. So yes, basically we have a grid which could have any number of rows or columns given certain constraints, and what we need to do is figure out how many islands there are in any one particular grid. So if we look at one of the examples here, we see that we have, all of these ones. These are going to be the land cells. And if a 1 is horizontally connected to another one, it's part of the same island. Or if it is vertically connected to another cell, it is part of the same island. So if we look here, all of these are either horizontally or vertically connected. And there are no other ones here, so it looks like, okay, we have one total number of island. So let's look at example 2. You see we have a 1 here, a 1 here, a 1 here, a 1 here. So that would make up 1 island. And you see these are diagonally connected? That doesn't count. So this by itself would be an island, and these, while they are diagonally connected, that doesn't count towards the number of islands, so this would be 3 islands total. Okay. So the way that we're going to solve this is we're going to create a for loop, a nested for loop that's going to go through each cell of the 2D array. And then we're going to call upon a method, which is called a DFS method, and DFS just stands for depth first search. And basically what it is going to do, it is going to recursively call upon itself and figure out, if there's a 1 in a horizontally adjacent one, or if there's a vertically adjacent one. And once it finds an adjacent cell that has a 1 in it, then it's going to mark that cell as visited. We're going to overwrite that cell to be a 0, and then the DFS function knows not to count that cell twice. And you're going to see that in the code later. So let's just jump straight into the code. It's going to make a lot more sense once we actually start coding. So the first thing that we're going to want to do is we're going to want to set up some boundary checks just to make sure that our input is within bounds. So if, for example, the grid is null, or if, for example, the grid.length, the total number of rows, if the length is equal to 0, if the total number of rows is equal to 0, or if the total number of columns is equal to 0, and we calculate the total number of columns by doing grid 0 dot length. If that's equal to 0, then we can just go ahead and return 0. Okay, now that we've figured out our bounds check, let's declare our variables. So first we need an integer type variable to count the number of islands. So I'm going to go ahead and call it island count. And I'm going to set that initially to be 0 because we have to start counting from somewhere. And also I'm going to often call upon the total number of rows and the total number of columns in my code. So I'm just going to create a nice little short form and do this arithmetic here and put it into a variable. So, okay, let's go ahead and do that. Int total number of rows. Int rows is equal to grid.length. Okay. Good. And int calls is equal to grid@index0 dot length. Perfect. Moving on, this is when we're going to iterate through each cell in the array, in the 2D array. Okay, or we could say in the grid. Now, so let's go ahead and write our for loops for some integer I, which is going to be our row index. So and we're going to start at index 0, of course, and we're going to stop the for loop when I is less. We're only going to run the for loop when I is less than total number of rows. And lastly, every time we go through the for loop, we're going to increase I by 1. And inside of our outer for loop, we're going to have our inner for loop. So let's go ahead and write that. We need to declare integer j equal to 0 initially. And j must be less than total number of columns, j plus plus. Perfect. Okay. And so this is going to go through, look over here, this is going to go through each individual cell of the character array, and we want to check initially whether it is a 1 character or whether it is a 0 character. So we write that here if grid at the indices of I, j, if it's equal to, and remember our single quotation marks here, so if it's equal to 1, then what are we going to do? We're going to increase the island count. We're going to increase it by 1. So we can just write simply island count plus plus. And then after that, what we're going to do is we're going to call upon the DFS that I mentioned earlier. Now, for our DFS parameters, we're going to need to, input the two-dimensional array as an argument. We're going to need to input the index for the row and the index for the j, so that we know exactly where we're talking about. Okay. Moving on, we can exit our for loop. Once we're done iterating through each one of the cells in the array, we exit our for loop, and we can finally return the island count. Now, you may be wondering, well, hey, Jake, why if every time that we come across a 1, and that's going to increase the island count by 1, then aren't we just going to be counting the total number of 1s? No, because of this DFS function here, it's going to be overwriting some of the 1s back over to 0s. That is to mark them as visited, and we're going to explore that a little bit more once we actually implement our DFS method. So let's go ahead and move on to that. So I'm going to declare this method to be private, void, let's give it the name DFS. And what do we take as parameters? We take a character, two-dimensional array by the name of grid. We also take the integer I for the row index, and we take the integer j, of course. Let's get our nice curly brackets here. Now we're actually going to have to redefine our, our total number of columns and our total number of rows and our total number of columns. I'm just going to use a copy paste here, copy pasta. So integer I is, integer rows is defined by grid.length. Perfect. And the integer calls is equal to grid at index 0 dot length. Perfect. So what do we do next? Well, quite simply, we have to do our base cases. We have to, if we're not at anything that is part of an island at all whatsoever, then we have to tell the the method to end itself. We have to return. So let's talk about our base case. Okay, base case is going to be if the cell is out of bounds, which means that we're at the leftmost side of the two-dimensional array, or we're at the rightmost side, the upmost side, or the very bottom of the array, and we don't want to call upon an element of an array that doesn't even exist. So we have to write a base case for that to get the heck out of the DFS if the cell is out of bounds, or not part of an island. If we see a 0 anywhere, then we're just going to return. We're going to get out of the DFS method, not part of an island. So how do we do that? Well, we're going to use an if statement. If I is less than 0. So if the index, you can't have an index that's less than 0. That would be, trying to call upon a row that is above anything that even exists. If I is greater than or equal to the total number of rows, so if we're trying to call upon a row that doesn't exist at the very bottom of the array, or same thing for j, same thing for the column. So if the column is, so if the index j is less than 0, doesn't make any sense, we need to stop our DFS. Or if j is greater than or equal to total number of columns. And lastly, the most important part is we have to check if the cell is not part of an island. So how do we do that? We say grid at the indices I, index j. If that is equal to 0, then we are going to very simply just return, end our DFS method. Now, the next thing that we must do is every time that we, every time that we don't have that if statement where we return, we need to mark that as visited. We need to mark the current cell as visited. So how do we do that? Well, we just simply say that grid. Oh, and I'm just realizing I made a mistake. This is a character array, so we have to surround this by single quotation marks. Same thing when we are marking the current cell as visited, we say grid at index I and index j is going to be set to, remember to use our single quotation, is going to set to 0. That's going to overwrite anything that we call the DFS method on, any cell that we call the DFS method on, that's going to set it to 0 so that we know that it's been visited. We're going to overwrite it in that way. Now, the thing is, we need to not just stop once we have hit a single 1. That wouldn't be good. We need to recursively call upon the DFS method. So we're going to explore the neighboring cells recursively. So how are we going to do that? Well, we're just going to call upon the DFS method recursively in the upward direction, in the downward direction, in the rightward direction, and the leftward direction. So let's go ahead and do that. How do we do that? Well, DFS, and put in our parameters. Grid, and I plus 1, J. We just need to do this 3 more times, I guess 4 total. So grid, and for I minus 1, that's going to be looking above where we were before. So I minus 1, J, semicolon, DFS, grid. Now we're going to look to the right. How are we going to do that? We can say I, J plus 1. And lastly, DFS, we're going to look to the right here. So we're looking at the grid array. We need to say I and J minus 1. Perfect. Okay. I'm just going to, look over this. Did we screw up with any of the times where we're asking, and we want the character, right? We want to surround it in the single quotation mark. So let's go ahead and run, see if everything's looking good. Perfect. Okay, both test cases are accepted. We can go ahead and submit our code. And bada bing, bada boom. We have an excellent solution here. Everything is looking good. It's got a great runtime that beats 99.65% of users with Java. And that will be everything. So thank you so much for watching. I hope you found this LeetCode coding tutorial helpful. If you want to see more coding videos like this, then make sure to smash that subscribe button. Okay, and I'll see you in the next one.